Okay, guys, so lesson 6.2, we get to multiply and divide with radicals. So 6.1, it was just, kind of reviewing the perfect squares, perfect cubes, those kind of things, knowing when to use plus and minus, knowing when you can and can't do it, all those details. Here we are multiplying and dividing radical expressions. So remembering when you can and can't multiply and divide. And also, we also have to talk about how to simplify these radicals, because that will be a big thing. So, the rules. If the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b equals the nth root of ab. What is that trying to say? What has to be true to be able to multiply radicals? What do you mean the radical has to be the same? The root, okay? So they have to have, officially that number is called the index. Whether it's a square root, a cube root, a fourth root, that's called the index. So officially it would be the indexes have to be the same. But yeah, they have to be the same type of root, right? Okay. Guess what about dividing then? If you have the nth root of a and the nth root of b are real numbers, then the nth root of a divided by the nth root of b is the nth root of a divided by b. So they don't have to be the same what's underneath a radical, just it has to be the same type of radical. So, this first set of questions, can you simplify the product of the radical expressions? Explain. So technically it's a yes or no question. Cube root of 6 times square root of 2. What do you notice? Yeah. On this first one, it's a cube root. There's a 3 right there. What's in that spot in the next one?
2.
If there's nothing there, it's an invisible 2. So, can I multiply these and make these some kind of root of 12? No. So, can you simplify? And the answer is going to be no. My explanation is going to be that the indexes, I just threw this word out at you a moment ago, the indexes, or in other words, roots, are different. B, cube root of negative 4 times cube root of 2. Can you simplify that? Because they are both cube roots. Okay, so officially my answer is yes, we can. Let's go ahead and do it. What is the cube root of negative 4 times the cube root of 2? Cube root of negative 8. Can I go farther?
Yes.
Do we know the cube root of negative 8?
Yes.
Okay. If you've been with me the past 2 days, we've talked about 8 several times. What is the cube root of 8? 2. So the cube root of negative 8 is negative 2. Now notice, you have a blue cheat sheet in front of you now. What's the very first cube root on there? 8. Okay? So that's kind of another helpful reminder. And C, can I simplify those?
Yes.
Okay, they're both fifth roots. So the answer is yes. I can simplify them. What is the fifth root of negative 5 times the fifth root of negative 2? The fifth root of 10. And what is the fifth root of 10? There's some decimal answer, but in terms of just simplifying without the calculator, the fifth root of 10 is the fifth root of 10. Yes, there is a calculator answer, but I don't care about that. Okay? For the most part, this chapter, I won't use the word never because I can't remember what all is at the end of this chapter. But for the most part, I don't ever want to know a decimal answer of a square root, cube root, fourth root, any type of root. I don't want a decimal answer. You're leaving it under a radical like that, or possibly simplifying the radical. Okay? Okay. Let's go down to example 2 here. They're just giving us one radical. And we are simplifying these radicals. You did this back in Algebra 1. Okay, or let me rephrase that. You were introduced to this back in Algebra 1. Is that a better way to put it? Okay. I'm not saying you remember it or, I don't know how successful you were at it, but cube root of 54 x to the 5th. Do we know the cube root of 54?
No.
I mean, you can plug it in on your calculator. You're going to get a decimal. I know it's not a perfect cube because is it on my list? No. It's somewhere between my 27 and 64, so it's not a perfect cube. Do I get to leave it like this? Is it simplified all the way? And I hate to say it, but kind of based on the directions, I don't get to leave it like this, do I? Okay. What do you see, Ethan?
You split up to 27 and 2.
Okay. So, by the way, I should have told you guys, have a calculator by your side today. Because as we get, this one wasn't as, the numbers aren't big. But as we have bigger numbers, you will want a calculator by your side today. That's part of how I teach this lesson, is I teach you using a calculator. Okay, so that's, Now, first of all, note, we're talking cube roots, right? So as you look at your paper, are you looking at the square root column? No, we're looking at the cube roots. As I look at the cube roots, 54 is not on the list. But what I want to know is what number on this list divides nicely into 54. So which of these numbers is a factor of 54? And so, my only choices are 27 or 8. Does 8 divide into 54? No, but 27 does. And so, depending on how much you recall, we're going to break this radical up. So I'm going to, and this time we're working with cube roots. I'm going to break it up into pieces. So first of all, 54. There's a 27 in there. 27 times how many? Times 2. And some people write them each in their own radical. I tend to just write them all into the same radical. You can do it either way. Now, okay, x to the 5th. Can I take the cube root of x to the 5th? Okay, how do I take a cube root of an exponent? No? You divide. Remember yesterday, if we were doing the cube root of x to the 5th, what were we always doing? Taking the 5, dividing by the 3. Does that work out to be a nice, neat whole number? No. Okay. What we need to do, kind of like the 54, we broke it up into 27 and 2, yes? Of these 5, what could you use of this that would be a perfect cube? I don't know if I'm asking that quite right. Okay, so x to the 3rd. If this had just been x to the 3rd, could we do the cube root of x to the 3rd and get a nice, neat whole exponent? Yes. Okay, so that is what I would call a perfect cube. So, do you see where I'm going with this? We're going to take our x's and we're going to break them up into the highest possible number within 5 that divides by 3. So closest number below 5 that divides by 3 is x to the 3rd. How many leftover x's are there? X squared. Okay, so that's my breakup strategy. Now as we go through, we're going to kind of separate pieces out. Do you know the cube root of 27? It is 3. Either my calculator tells me 3, or if I count down on my list, 2, 3. So since I know the cube root of 27 is 3, where do I put that 3 now? Outside the radical. It's going to go out front. Okay. Do you know the cube root of 2? No. So where's that 2 have to go? It stays under the radical. Do you know the cube root of x cubed. X to the first, because 3 divided by 3 makes it x to the first. So where do I put that x? Out front. So these two guys both went out front. Do I know the cube root of x squared? No, because if I do 2 divided by 3, it's a fraction. I can't have a fraction. So where's that x squared going to stay? Under the radical. Mine ended up kind of spaced out. But final answer, 3x times the cube root of 2x squared. You don't have to have quite the spacing that I do. I didn't intend for that. Here's what you do have to be careful of. What is this little 3 here? It's part of your radical. You want to make sure, however you write it, that it looks like it's part of that it's the index on the radical and not an exponent on the x. That's what I will warn you of. Questions on that one? Came back to some of you, I could tell. I don't know if it came back to all of us yet, but you ready to try B then? Now, always pay attention. What type of root is this I'm doing? This is another cube root, right? So you've got to be very careful of which column should I be in. The cube root, okay? Do I know the cube root of 128? Nope, not on my list. Okay? Do I know the cube root of x to the 7th? No, because does 7 divide by 3 evenly? No. So what do I need to do? We're going to break this up into pieces. Now, when it comes to 128, this is where I say have the calculator. And you may or may not need the calculator in some of these, but 128, which of these numbers does it divide by? 64. Now, and let me specify, always take the biggest number it divides by. Okay? Because technically 128 also divides by 8, doesn't it? But you haven't simplified it all the way unless you take the largest perfect, whatever, in this case, perfect cube. So it divides by 64. So how am I going to split this up under the radical? 64 times 2. Because 64 is a perfect cube and times 2 is the leftover. What about x to the 7th? Sorry, what was it? Not exactly. Yeah. What is the largest number within 7 that divides by 3? 6. Do you see why I'm saying that? If you leave it as x to the 3rd and x to the 4th, you still have a perfect cube within x to the 4th. And so, easiest way for me to do this is say x to the 6th and x to the 1st. I still have a total of 7 x's there, right? 6 and 1 is 7, so I have a total of 7 x's. 6 divides by 3, so that'll work out. The 1 is the leftover. It's kind of like, make sure you use the 64 and not the 8. Make sure you use the x to the 6th and not the 3rd. Okay, do you know how to finish this off then? Do you know the cube root of 64? 4, so where does that go? Outside. Do you know the cube root of 2? No, so where does it go? Stays inside. Do you know the cube root of x to the 6th? Do you guys agree with him? Yes. Because 6 divided by 3 is x squared. Do you know the cube root of x to the 1st? No, so what about it? Stays under the radical. So my 64, my x to the 6th, those moved out. Everybody else stayed. And you see how it gets confusing between the exponents and the index? I've got that x squared and I've got that 3 right beside it. It looks kind of, you have to be very careful how you write them. Okay. You can use the same process with square roots, right? We practiced using cube roots right there, but you can use the same process with square roots. Example 3. What's different here? Okay, square roots instead of cube roots. And instead of just having 1 to simplify, officially we have 2 to multiply. Now, I struggle with how to teach this because there's so many different ways you could do one of these problems. And we won't all do it the same way. One option is we could simplify the first square root, simplify the second square root, and then multiply the remaining pieces together. If you do that, you sometimes have to simplify that new square root again. Just kind of depends on the situation. The advantage of doing it that way is you have smaller numbers to work with at the beginning. The disadvantage is you sometimes have to go back and resimplify if you don't get everything. The other way, which this is how I'm going to teach, is I'm going to say, let's multiply these to begin with. You have to work with bigger numbers then, but you have a calculator by your side, so I don't feel as bad about that. Let's multiply them to begin with, and then simplify them. And if you don't like my way, you're more than welcome to try the other way and meet me in the end. Okay? So first of all, what do these square roots multiply to be? We practiced with exponents the other day. You guys didn't much like me for it, but this is why. And 720. Okay, so 72 times 10, 720. X to the third times x to the first adds, and you have x to the fourth. Y to the second, y to the third adds, and you have y to the fifth. Officially, we've multiplied them. You might get a point out of me on the test if you just multiply them and stop there. Strongly encourage you not to do that. It says what is the simplest form. So, what are you doing? Simplifying them. Is 720 a perfect square? Okay. And honestly, can I tell by looking at my list? No, because my list ends at 400. Okay. You can make a bigger list if you want a bigger list. I have to stop somewhere. Okay. And honestly, most of the time, this will cover what we need. Occasionally, I end up wanting to go past this and wish I would have made it bigger. So, how do I check and make sure that 720 isn't a perfect square? You grab your calculator, you do the square root of 720, and, okay, it's a decimal. I can't just take the square root. Occasionally you can, so beware. Okay, so how's this calculator going to help me?
You can divide 720 by the other perfect square.
Yeah. Take your list. What does 720 divide by on this list? Now, here's the deal. Here's the catch. You have to try and find the largest number 720 divides by. If you just say, oh, 720 divides by 4. Well, I'm not going to disagree. However, you're not going to have it fully simplified. Okay? So then, if you just do 720 divided by 4, you're going to have to take whatever you remain and keep pulling out more perfect squares. So, I would always start on the bigger end of the list. Or if you find it divides by like something like 4 and 9, you can kind of jump. If it divides by 4 and 9, I know it divides by 36. You'll kind of see how they work together. So are you guys taking your calculator and trying these out? I mean, obviously, 720 doesn't divide by 400. Does it divide by 361? No, I get a decimal. And I'm just demonstrating for those of you not sure what I'm doing. Does it divide by 324? No, I get a decimal. Does it divide by 289? No. Does it divide by 256? No. It's not going to divide by 225. Does it divide by 196? No. Does it divide by 169? No. Does it divide by 144? Yes. Okay. That was kind of the long way. but sometimes you'll end up using the long way. Okay? So, what am I going to rewrite 720 as under my radical? Under my radical still, I'm just going to write it as 144 times 5. If you found something like 36, okay, you would have had 36 times 20. Well, 36 is a perfect square. Realize, is 20 done? No, because 20 can divide by 4. So you have to keep going if you don't find the largest perfect square. Okay. What about x to the 4th? Can I take the square root of x to the 4th? Yeah, what's my invisible root here? 2. Is 4 going to be able to divide by 2? Yeah, so I'm just going to leave x to the 4th underneath there. My point is I don't need to break it up. Y to the 5th. Okay, I can't do 5 divided by 2 nicely. So closest number to 5 that does divide by 2. And that's 4. So I'm going to make this y to the 4th and y to the 1st. So all I've done there is I've kind of made my problem easy to finish because I've got all the pieces written down. Oops, that's not what I want to do. Okay. Square root of 144. Can you do it? 12 and it goes outside. Square root of 5 stays under the radical. Square root of x to the 4th. Okay. 4 divided by 2 makes it x squared. Square root of y to the 4th. 4 divided by 2 makes it y squared. Square root of y to the 1st. I can't do 1 divided by 2, so I leave y under the radical. Here's what I'll say. If you did this a different way, you still need to arrive at my same answer. Okay? So if you didn't grab the largest perfect square, you'd still need to keep going until you get to that answer. So somehow or another, you should have that same answer. Now, if you punched in your calculator the square root of 720 at the very beginning, and your calculator told you 12 square root of 5, those are the calculators I'll be taking away on the test. And you have to use one of mine or bring a different one of your own. Okay? Like Lily, I'm assuming your calculator, if you punched in 720, depending on the setting you have, would tell you 12 square root of 5. Okay? And I get you can change your setting. However, I don't let you guys use those on the test because you can change that setting. Okay. Questions on this one? Got it? Okay, let's try B then. What are you guys doing first? There's different ways we could do this, but what am I going to recommend? Put it all together. If I put this all together, it gets to be big, I get it, which is why I struggle with which method do I teach. 45 times 35 is 1,575. Again, I only feel slightly guilty because what do you have beside you? Calculator. I would feel really guilty if you didn't have calculators, okay? X to the 6th, y to the 7th. Okay. I'll be honest, the first thing I always do on numbers that are bigger than what's on my list, I grab my calculator and I make sure 1575 isn't a perfect square itself. You always get those random ones that you don't know. Okay, it's not a perfect square. Okay, are you playing around on the calculators? 1575. Now, I see that it ends in 75. That gives me a hint. If it ends in 75, it divides by things that have quarters in them, right? So I've got a couple that I would go to quicker than others. Are you finding anything? 225? I like it. So, if you found 225, it's 225 times what? 7. Well, if it's 225 times 7, I definitely feel like I got the largest perfect square because 7 is not going to have anything in it. X to the 6th, what do you know? It's divisible, it'll be okay, so I'm going to leave it as x to the 6th. Y to the 7th. Okay, 7 does not divide by 2, but 6 divides by 2 and leaves me with 1 left over. Square root of 225? And this is where, if you're not very familiar with that list, you might want to have the labelings on your blue paper, right? Might make it a little easier there. Square root of 7. Square root of x to the 6th. X to the 3rd is 6 divided by 2. Square root of y to the 6th. Y to the 3rd is 6 divided by 2. And square root of y stays under the radical. I'm going to do a quick side note here before I flip back to the other page. I want to play the what if game real quick. If we had used 1575, did some of you find the 25 first, I'm guessing? Let's play the what if game. What if I'd used 25 because I didn't realize there was something bigger? It would have been 25 times 63. Okay, here's the catch. Yeah, we know the 25 is going to be a 5, but what do you know about 63? 63 has what in it?
Another perfect square.
Another perfect square, right? 63 divides by 9. And so what you could do is you could break this up again so that 25 is 25. 63 is 9 times 7. And so do you see where this is going? Square root of 25 is 5. Square root of 9 is 3. Square root of 7 stays square root of 7. And so then this is 15 square root of 7. Did I get the same results? Can you use that if you prefer that? By all means. You just have to watch that remaining number. 63. Does it have any more perfect squares in it? That's the only catch there. So if you'd prefer to work with those type of numbers, I have no preference. Honestly, for me, when I do a problem, it just depends on the problem. I don't necessarily have, this is the way I always do it. It just depends on what I see first. So, okay, how are you feeling about multiplying? Getting it? Let's look at a little bit of dividing. I don't think, yeah, we're not getting through all this today. I have several of these sections in this chapter where we don't get through.
We should decide.
Nah, we'll keep going a little bit. It'll make it better for tomorrow, Friday, that if I keep going now, I won't have as much to do tomorrow, which gives you more work time at the end of class tomorrow. And so, okay, guys, dividing. There's a lot of different varieties of dividing here. Okay? We've got some dividing problems up at the top. We've got some dividing problems down at the bottom. And There's easier dividing ones, there's harder dividing ones. As you look at the square root of 18x to the fifth divided by the square root of 2x to the third, what do you notice?
They have the same index.
Okay, so first of all, they have the same index, right? They're both square roots, so can I divide these? Yes. Do the numbers underneath them actually divide?
If you divide them,
And think about this. Technically, you can write this as one square root. You can write it as the square root of 18x to the fifth over 2x to the third. Look at that fraction.
that turn into a square root.
Yeah.
Okay.
Simplify the fraction. What is 18 divided by 2? 9. What is x to the fifth divided by x to the third? X to the second, because we are now subtracting. You know, all those exponent rules you guys hated me for. This is why we reviewed them. So I haven't taken any square roots at this point. I just know that 18 divided by 2 is 9. X to the fifth divided by x to the third is x to the second, because I subtracted the square roots. Or subtracted the exponent, excuse me. Now what? Yeah. Square root of 9? 3. Square root of x squared. X, because that's when you're doing the 2 divided by 2, right? And so that is x. Now, technically, let's see. Okay. I should double check this. I'm 99% sure. Okay, so lesson 1, you had to deal with the absolute value sum, didn't you? Okay? There are problems that you can only get right if you put absolute value in the appropriate places. From this point forward in this chapter, the book's rule is we are going to assume the variables are positive, and so you don't have to consider absolute value. So only back in lesson 1 do they have us worry about absolute value. Otherwise, we would have to be considering, well, and I should have mentioned even on the front side, we would have had to be considering absolute value on all of those pieces that came out of the radical. Okay? Anytime it was a square root. So, good news is we only worry about that in lesson 1. Because otherwise that would consume a lot of time and energy trying, figuring that all out. So, okay. B? You ready to try B? Can I divide them?
Yeah.
And there's really 2 parts to that question. Are they the same indexes? Yeah. And then let's check and see. Before I start trying to do any cube roots, can I divide the underneaths there? So if it helps you as a visual, you can write it as 1 cube root. So 162 y to the fifth over 3y squared. I saw people grabbing calculators. That's good. So I'm still under a cube root. Does 162 divide by 3? 54. And what is y to the fifth divided by y to the second? Y to the third. Okay. 54. Can I do the cube root of 54? No, it's not on my list. So do I just leave it? If there's no perfect cubes in it, we leave it. But if it can split, we need to split. Does 54 divide by something on my perfect cube list? And if you don't know, you grab the calculator and check, yes? Okay, so I'm going to split this. 54 is going to be 27 times 2. Can I do the cube root of y cubed? Yeah, so I'm just going to leave that as y cubed because 3 will divide by 3. So, cube root of 27 is 3. Cube root of 2 stays cube root of 2. Cube root of y cubed. Y to the first, because 3 divided by 3 is 1. Okay. One more. C.
Well,
What can you tell me?
divide.
Okay. They divide. They're both square roots. So it's the square root of 50 x to the 6 divided by 2x to the 4th. So what do you know when you simplify that fraction? 50 divided by 2? 25. X to the 6 divided by x to the 4th. X squared. What's the square root of 25x squared? 5x. Okay, so notice all of those division problems. We were real nicely able to divide them out into nice, neat whole numbers and out of fractions, and we were able to nicely take the square roots or cube roots. If you take a glance at the bottom two, does that happen? Now, if you start glancing at the bottom two, it's 5 over 12 and 7 over 5. We're going to have fractions. And so what we'll talk about tomorrow is the fact that, do you remember, you cannot have a radical in the denominator? Okay, or you can't have a fraction left under the radical. So we tomorrow will review rationalizing. I don't know if you guys remember that or not, but we'll review rationalizing tomorrow. So you can get everything done in your homework except where it's rationalizing. So you can really get a lot of the homework done already. Okay? We'll rationalize tomorrow, and then you guys will have some work time to finish up the homework.